Leibniz cared about his readers. Unlike Newton, who wrote the Principia Mathematica in a difficult style, Leibniz valued clear communication. As he developed the concept of calculus, he made sure to clothe them in a smart and well-fitted symbols like D. In mathematics, delta signifies change. Suppose I am running from the home, and if x is my distance from home, then delta x is the change in that distance over a certain span. Let's say 16 km, because this is my video and I can lie if I wish. Now if t is the time, then delta t will be the time elapsed during my run. Let's say 2 hours, because I am not the Bolt. What was my speed? It's simple, delta x divided by delta t, which gives 8 km per hour. But we do not deal with simple things. So what about my speed at precisely 1 pm? To answer such questions, we need a derivative. A derivative, you may recall, is an instantaneous rate of change. It does not analyze over a span of 2 hours. It zooms in on a single moment, a freeze frame. But that poses a problem. During this infinitesimal span, no time elapses, and I cover no distance. Delta x and delta t are both 0, and 0 by 0 is now defined. So now what? Here comes Leibniz notation. Instead of delta x and delta t, we consider dx and dt, infinitesimal increments of position and time. Hence my speed at 1 pm is the derivative of x with respect to t. There is deception. Dx and dt are not really numbers, and you cannot really divide them. The notation is not literal. It's more like an analogy, but that's exactly what makes the symbolism so powerful. Suppose you and I make a product and we want to make money, and there is only one output variable that matters to us, is a profit. To maximize profit, we can set prices too low, say 5 rupees, but that would become the work of charity, not a business. If we increase the prices to 5.5 rupees and we sell 10 lakhs quantity, then we can get an extra 5 lakhs as a profit. But we cannot increase the prices too high, because if we increase the prices too high, say 15,000 rupees, then perhaps some billionaire will buy one or perhaps not. So to know whether we should increase the price or not, we need a derivative. If we raise the price by little, then how will that affect our profit? Positive derivative means increasing the price would boost the profit. In other words, we are undercharging. Negative derivative means lowering the price would boost the profit. In other words, we are overcharging. We want to find a special moment, the price at which the derivative is precisely 0. Derivative is just a slope. Maximum is a moment of transition, when your slope switches from positive to negative. Meanwhile, a minimum is just the opposite, a moment when the slope switches from negative to positive. The logic is quite plain. Go until the things stop getting better and are about to start getting worse. That's the best you can do. Here at a maximum point, derivative switches from positive to negative. It means the derivative is decreasing. So the derivative of derivative at a maximum point will be negative. At the minimum point, the derivative is increasing. So the derivative of derivative at the minimum point will be positive. Thanks for watching.